All right, chemistry kids, here we go. Now we're getting into a little bit more math today. We're going to be talking about mole calculations. Okay, and mole calculations are going to be the basic information you're going to need for when we start doing stoichiometry and more complex calculations which involve chemical formulas. Whereas right now we're just using, chemical reactions. So right now we're just doing calculations with chemical formulas. After this we'll be doing we're doing math with chemical reactions. And the mole is the ideal unit that chemistry uses, okay? So the first big question is, here's our mole calculation part. What is a mole? Well, the mole is an amount of any substance, okay? And if you want to get specific about this, okay, not Pacific, specific, all right, you got to say it is a mole of amount compared to a carbon atom, all right? But really it's an amount of substance. So just realize it's an amount we use in chemistry that is going to allow us to calculate things for different elements. And the number you need to realize that comes up big with this is Avogadro's number. And it's 6.02 times 10 to the 23rd. And this could be atoms, or depending on what you're dealing with, molecules or formula units. All right. Formula units or molecules. Okay, so really this is the amount of something. It's like a dozen, it's like a quart. It's a measurement of molecules, basically. All right, so a mole is a measurement of molecules. Let's just keep that in our brain. It's a chemistry calculation. All right, so it's a measurement. Let's keep building off of that. So the nice thing about when we do the math and how do we convert from different things to, molecules to moles. I spelled moles wrong here. Way to go. All right, things like that. What we need to use and what you have available to you is something called the mole wheel. All right, it's on the back of your periodic table. It looks like this. All right, so then to answer these questions, you have to look at this mole wheel. So notice it has arrows going from here to here, there to there, and so on and so forth. And it has little calculations you can use. All right, these are going to be quite useful. All right, so using this, let's take a look. So the first question, how do I convert from moles to number of things? From moles to number of things. Well, what do I got to do? Here's my calculation right here. So the calculation is Avogadro's number on top divided by 1 mole, because I want moles to cancel out. So really what you need to do is you multiply by Avogadro's number. So I need to multiply by 1 mole, because Avogadro's number is always equal to 1 mole of anything, times 10 to the 23rd. All right, so whatever you're given here, that would be your given, and then you would multiply by this. The mole should cancel out, and you should get, depending on what you have, atoms, numbers of things, formula units. It depends on what you got, and we'll talk more about what you're going to get, or how you're going to identify what you get in terms of molecules, atoms, and formula units later on. So to go from moles to number of things, you're going to go with that. So then think of it backwards now. Well, how do I go from number of things, which would be atoms, formula units, or molecules, to moles? Well, I start here, and I go here, so my step's this. So now instead of multiplying by Avogadro's number, I divide by Avogadro's number. Because Avogadro's number is going to be on top, or on the bottom here, so I divide. So your given's going to be here, moles is going to be on top, and then you divide by that. And there's the simple calculation. And that should work every time. And then whatever unit you have here, whether it's atoms, formula units, or molecules, that should be your label here, which should cancel those ones out. Let's keep moving on. How do I convert from moles to grams? Here's moles. Oops, can't see that, can you? Move it up. There. How do I convert from moles to grams? Moles to grams. Okay, look at the arrow. Here's my calculation. MM stands for molar mass. So basically, how much does the formula weigh? I'll sometimes call it formula mass. Some people don't call it formula mass. Some people call it molar mass. Just realize this is the weight of the compound on the periodic table, all added up and everything, the number of atoms together. So you'll have your given, and you'll have your molar mass on top, or formula mass. And to get rid of moles, you put moles on the bottom. right? And moles we cancel out. So mm is molar mass, but just realize that molar mass and formula mass, at least when I talk about them in class, they mean the same thing. It's just the weight of the formula on the periodic table. Use the atomic weights, add them all up. That's just really how you do it. Okay? And then to go backwards on that, how do I convert from grams to moles? Grams to moles. Now I divide by my formula mass. So it goes on the bottom. So say whatever given you have here, set it up. I'm going to have 1 mole on top because that's what I want to go to. And I have my molar mass or formula mass in the bottom. And your answer should be in moles. And this is going to be obviously in grams. This is going to be in grams. This is going to be, atoms, formula units, number of things. This will be number of things as well. So to kind of hopefully help you with any confusion, how do I find the molar mass, which is the mm that I'm referring to? That's the mm that's on this periodic, that's a mole wheel. Okay, how do I find it up? Add your number of atoms of each element times their atomic weights / mass, whatever you want to refer to. So for example, let's say I had a formula like, let's say I had H2O. Okay, 2 hydrogens, but I'd go 2 times whatever hydrogen weighs, which if you look on the periodic table, hydrogen weighs 1.0079. Then I have 1 oxygen, 1 times whatever oxygen is. Let's see what we got over here. Oxygen is 15.99. Okay, you do those calculations, and these answers added together will be what we should get. And let's do some calculations so we know what's going on. So let's see. 2 times 1.0079 is 2.0158, and then obviously 15.99 times itself. So I add these two together, and I go plus 15.999 equals 2.0158 times 15 point times, what am I doing? 2.0158 plus 15.999 equals, and your answer should be 18.0148. And this is, remember, this is going to be atomic mass units, which you could just say it's in grams. And that is your formula mass or molar mass of water. So it's just like how we did percent composition stuff. That's just part of the percent composition procedure. All right? So make sure you remember how to do the formula mass or where to get that from. So I give you a very big mole wheel, which is really just the same things on the back of your periodic table, but this is one that's going to be useful when we start converting them into different compounds. So let's set it up. Let's do some practice problems here. So on the bottom, we have 7.84 grams of iron, and we have to convert it to moles. All right? So 7.84 grams of iron, we have to convert this to moles. So moles go on top. So here's my conversion. I look up what iron weighs on the periodic table, and iron weighs 55.845 grams. Okay, this is grams of iron. This is moles of iron. So grams of iron cancels out. I pick up my calculator. I do the calculation. 7.84 divided by 55.845. I get an answer of 0.140 grams. Oh, no, sorry, this is moles. Moles of iron. Okay, so that's my answer for that. All right. So again, this is my molar mass or formula mass that I find from the periodic table. Just divide them, it's on the bottom, and then they should cancel out. Let's try the other one. Now, 56.8 moles of F2 into grams. So my starting product is 56.8 moles of F2. So because I want to get rid of moles, 1 mole goes on the bottom, and my grams of F2 goes on top. Now notice the formula is F2. That means I need 2 fluorines. All right, so 2 fluorines, 2 times what is fluorine? 18.998, which would be 37.996. All right, so that's my weight of F2. Okay, 2 fluorines. Now we pick up the calculator. Moles of F2 cancels out. Now 56.8 times 37.96, so times 56.8 equal to, and your answer should be 2158.1728. That's grams of F2. But sig fig answer would tell us that we only need 3 in our answer. So when we talk about sig figs, the answer should be 2160 grams of F2. All right, so here's your calculator answer. Here's your significant digit or sig fig answer. All right, so remember, that's my formula mass or my molar mass. Let's try some extra calculations with the mole wheel. And next part of this is just going from molecules. So we start with molecules, we're going to moles. All right, so if we look at this, here's molecule, whoa, there we go. If we look at this thing that I gave you, or either one, going from molecules to moles, all right, that means we divide by Avogadro's number. So 2.45 times 10 to the 12th, divide by Avogadro's number, and moles go on top. And notice this is molecules. All right, and then the moles should cancel out. So there's your setup for that one. And then for this one, so you should just be dividing this divided by that. All right, make sure you punch in your calculator right. If you don't know how to punch in your calculator, we'll talk about that in class a lot. And then say we're starting with moles, and we want to go to molecules. So then you go Avogadro's number on top to molecules. And there's your setup for that one. All right, so this times that will be your answer. So I hope this helped. If you use the mole wheel on this paper or on the back of your periodic table, they should be very helpful because they tell you the steps you need to do. Just make sure you cancel things off and you should be good. All right, have a good one. We'll talk to you later.